Okay, I do not want you to write this down. I'm just relating what we're doing now with functions into stuff that we've already done. So all I want you to do is to think about how we've already done this. So don't write this down. If 270 people traveled to an event, there were 7 buses and 18 others in cars. Find the number of people on each bus. So this is what we've already tested on. So the first thing we need to do is to define the variable. So we're going to say x equals the number of people on each bus. And I know that there's a total of 270 people that went. So the number of people on each bus times the 7 buses plus the 18 that are in cars should total 270 people. So we've already done this. What you need to notice, though, is that we've only had an x. So starting this unit, when we are talking about functions of input and output, we are going to be having 2 variables. So you have already seen this before. Okay, so we're just kind of stepping it up one little notch. So when we have these problems, I just wrote them out in advance because it was going to be easier for me. So make sure that you, as I'm working through them, that you pause to give yourself enough time to actually write each problem down. Okay, so what we are doing is we are going to be writing a function rule given a situation. Okay, so that is our goal. We're going to be able to read a story problem or word problem and be able to write a function or an equation from that. So if I'm reading this, it says a plumber's fees, F, are $75 for a house call and $60 per hour, H, for each hour worked. So when we are working on these problems, we are trying to figure out, okay, so the plumber's fees, F, if we know the number of hours that the plumber actually worked, plus the $75 house call, that's going to give us our total fees. So if I have H, so if I know $60 per hour, which means $60 times each hour that the plumber is going to be there, plus the 75 for simply showing up, that is going to give me the plumber's total fees, F. If you're thinking about this in terms of a input-output table, typically we would think of X and Y. Well, we don't have X's and Y's for this problem, but we have H's and F's. So if I input the number of hours, that's going to spit out the total cost of fees. So H is going to be my input. F is going to be my output. So if I know the number of hours, I'm going to find the number of fees, or the total amount of fees. So let's say that he works 1 hour. So if he works 1 hour, plus the $75, that's going to give me my total amount of fees. So 60 plus the 75 is going to equal my total number of fees, which gives me $135 for fees. Okay, so right now what we are focusing on is we are writing the rule. So we are focusing on that. This is the table that we can create. So if we have 2 hours, so 60 times 2 gives you 120. 120 plus a 75 gives you 195. Let's say that he works 3 hours. 60 times 3 gives you 180. 180 plus the 75 gives you $255. Okay, so what we are going to be doing in the next video is we are going to be going from a table and creating this. Okay? So let's go on to the next problem. Again, if you need to pause it, do it so you can write down a word problem. The total cost C for P pounds of copper if each pound costs $3.57. So think about for a minute, what do I need to know? If I know the pounds times the total cost of the copper, or the cost per pound for the copper, that's going to give me the total cost of the copper. So if I know that the cost per pound is $3.57, and I know, let's say I bought 1 pound, we're just going to put a P in there, then that is going to give me the total cost. In an X and Y table, actually I get out of the habit of X and Y, it's a function table, so the input would be P, and the output would be C, which is the cost of the copper. So if I input 1 pound, so 357 times 1 pound is going to give me a cost or an output of 357. If I purchase 2 pounds, so I'm going to take my handy dandy calculator and do 357 times 2 is going to give me a cost of $7.14. What happens if he purchases 2.5 pounds? So now I have 3.57 times 2.5. Now that is going to give me 8.925. This is one of the exceptions to the rule. If we are creating the table, I guarantee that no place is going to let you round that down to 92 cents, and they're going to make you charge you rather $8.93 instead. Again, pause if you need to. For example 3, leave yourself a little bit of space because it is a 2-part question of A and B. So we have a club charges an annual membership fee of $65 plus $2 per visit. So we are going to write a function rule for the total cost of belonging to the club if you make V visits in a year. So at $2 per visit, plus, remember I've talked to you about the flat fee, so that gets added in, is going to give me the total cost of the membership. So $2 times the number of $2 times the number of visits plus a flat $65 is going to give me the total cost. So I'm looking at a X and Y chart. That would be the visits and the cost. So again, this is my answer that I'm looking for this one. We have just written a function rule. And then I'm going to move down to part B. How much would it cost if you used the club 15 times in a year? So 15 times in a year, even though it doesn't say it, that's talking about the number of visits. And our function rule is 2V plus 65, with the number of visits being 15. I'm going to plug that in to find my total cost. So I have $30 plus the $65 is my total cost. So I get $95 is the total cost if we visited 15 times. So that is how you write a function rule given a situation. So because it's a function rule, we are looking at 2 variables, an input and an output.